Hello everyone, today we are going to focus on the projectile motion and we are going to solve some examples of projectile motion. Let's start with the first example. A ball is projected horizontally from the top of a hill with a velocity of 30 meters per second. What is the height of the hill if it reaches the ground 5 seconds later? Initial velocity, let me change the color. Initial velocity, we know, is equal to 30 meters per second. And the flight time t is equal to 5 seconds. We need to find the height of the hill. Let's say it's h. Let's first draw the picture. This is the ball, V naught, which is equal to 30 meters per second. This is also equal to horizontal component of the velocity, and the vertical component of the velocity is 0. You know y is equal to 0 because it's projected horizontally, and the horizontal component of the motion is, or horizontal component of the velocity is always constant along the motion. Now we need to find the height of hill. Let's say this is h. We know that h is equal to vertical component of velocity times flight time plus 1 over 2 g times t square. Then h is equal to the vertical component of ball is 0, or the velocity is 0, 0 plus 1 over 2 times g is negative 10 times t is 5, then 5 square. Height is equal to 5 times negative 5 times 5 square, which is equal to negative 125 meters. Negative 125 meters means height is below the reference level. So absolute value of h is equal to 125 meters. That's the answer. Also, negative 125 meters is the answer. Now let's go to the next question. Yes, this is the second question or second example. A ball is thrown horizontally 20 meters above the ground with a velocity of 5 meters per second. How far from the base of the cliff will the ball land? Height of the cliff is 20 meters. And the initial velocity of the ball is 5 meters per second. We need to find the horizontal distance, x. Now let's draw the picture. This is the ball. E naught is equal to 5 meters per second. This is the horizontal distance x. We are going to calculate the value of x, and the height of the cliff is 20 meters. Okay. Again, in this motion, the vertical component of the velocity is equal to 0 because the ball is projected horizontally. And we know that, again, h is equal to vertical component of the velocity times flight time plus 1 over 2 gt square. And the height of the cliff is negative 20 meters, equal to, because it's below the reference level, okay, it will be equal to, and the initial component of the vertical component of the velocity is 0, means 0 plus 1 over 2 times acceleration is negative 10 times t square. Then negative 20 is equal to negative 5 t square, which implies that t is equal to negative 20 divided by negative 5 is plus 4, square root of 4, which is equal to 2 seconds. This is the flight time. We know that the horizontal component of the velocity is, we know x is equal to 5 meters per second, and it's always constant along the motion. That means x is equal to, x times flight time, which is equal to 5 times, initial velocity is 5 times, flight time is 2 seconds, then it's equal to 10 meters. That's the answer. I hope it's clear. Now let's go to the next example. This is the third question. A ball is projected vertically upwards with a velocity of 30 meters per second. After what time is it 40 meters high from the point of projection? Let's first draw a picture. Let's say this is the ground level. A ball is projected vertically upwards. Then it moves like this. And returns back to the ground. It says after what time is it 40 meters high from the point of projection? That means height h is equal to 40 meters. This is the direction of motion. And the velocity of the ball, initial velocity of the ball is 30 meters per second. Again, we know that h is equal to vertical component of the velocity, not y, times flight time plus 1 over 2 g t square. It says after what time is it 40 meters high? That means height is 40 meters. 40 is equal to the initial component of the vertical velocity is 30 times flight time plus 1 over 2 negative 10 times t squared. And it is 40 equal to 30t, and it's minus 5 t square, which implies that 5t square minus 30t plus 40 equal to 0. This is a quadratic equation. We need to solve it for the flight time. Let me change the color. If we divide both sides by 5, it will simplify to t square minus 6t plus 8 equal to 0. Then we can factor it. T minus 2 times t minus 4 equal to 0. That means t is equal to 2 or t is equal to 2 seconds or 4 seconds. And therefore at 2 seconds, the ball passes 40 meters high and at 4 seconds it passes the same height on the way down. This is height up 2 seconds and this is down at 4 seconds. I hope it's clear. Okay, let's go to the next question. This is a question 4. A ball is thrown horizontally from the top of a 20 meters high hill. It strikes the ground at an angle of 45 degrees. With what speed was it thrown? Let's draw a picture. This is the ball. It's thrown horizontally. It moves like this. And the angle of velocity when it strikes the ground is 45 degrees. It says with what speed was it thrown? Since it's thrown horizontally, we need to find the horizontal component of the velocity. And height is 20 meters. We use the formula again. Height is equal to vertical component of the velocity times flight times plus 1/2 gt square. The height of the hill is 20 meters, but it's below the reference point, so it's negative 20 equal to, and the vertical component of the velocity is 0 plus 1/2 times, and the acceleration is negative 10 times t squared. Then negative 20 is equal to negative 5 t squared, which implies that t squared is equal to 4, and implies that t is equal to 2 seconds. When it strikes the ground, it has a vertical velocity y and a horizontal velocity of x. We know that y square is equal to, we know y square minus 2g times h. And this means v naught vy square is equal to 2 times this part 0 and 2 times acceleration is negative, so it's plus 2 times 10 times negative 2 times 10 times h is negative 20. It's equal to 400. That means the vertical component of the velocity is equal to 20 meters per second. Since the angle is 45 degrees, the horizontal component of the velocity is equal to the vertical component of the velocity. It is equal to horizontal component of the velocity. And we know that the horizontal component of velocity is always constant. That means the ball is thrown with a velocity of 20 meters per second. It is equal to 20 meters per second. If it's 20 meters per second when it reaches the ground, that means it's also 20 meters per second at this point. And it's always constant along the motion. I hope it's clear. Please subscribe my channel and like it. Thank you very much.